Hey everybody. In this lesson, we're going to continue what we started previously, and that is how to describe some data. So I'm going to open up the script where we left off last time, and that I'm just going to go up here and click Recent, and that's our class script that we have. And I noted that you can annotate these scripts with hashtags and attach the files before using them. And then we started talking about variables, and we're going to spend a lot more time in Module 5 on variables. But we started talking about displaying information about variables that are categories. And I'm going to click on this over here so you can see the hospital data over here. That's just information. And we saw, we identified gender as a category and marital. And then we had whether people returned within 30 days to the hospital and whether they had a spouse or partner. Age cat, by the way, is a category of patient's age. But you'll notice that those all those variables were made up of words in some way. Even this age cat is 80 or older. They're not really made up of numbers, but a lot of data, and again, data is just a fancy word for information, is used in research that is numbers. And so we need to start addressing that here. So we're going to spend some time today talking about summarizing variables or pieces of information that are made up of numbers. So we're going to go into our script, and I'm going to make a note that we're going to display information about variables that consist of numbers. And I'm putting in parentheses, these are numeric variables. We're going to talk about that a little bit more. This is actually a little bit easier in R. We're not going to go sort of through the gyrations that we did previously, but we are going to spend a couple of times on this, a couple of weeks, so we can start differentiating one from the other. Okay, so I'm going to, when we began the summary function previously, I'm just going to rerun this. We summarized an entire data set. And again, when we click on this here, it summarized every single variable that is in this data set. We can actually use the summary function on a variable that is numeric specifically. So I'm going to type summary, and we're going to pick a variable here that's made up of numbers. I don't want to go into these cats variables right now. Why don't we look at age? This is the age of patients. So I'm going to put in here, summary, age, and I'm going to just run this, and you will see that we get a bunch of information about that single variable age. And this is interpreted as such. I'm going to bring this up so it's a little bit easier for you to see. Okay. So this tells us that the youngest age, this is the min, the youngest age of the patient in our data set is 64.46 years. This is based on admission date and the person's birth date. The median is the middle value of all the patients in this data set. So if we listed all the patients in the data set from youngest to oldest, the middle value, or the 50th percentile, is 75.5. The average is 76.13 years, and the oldest is 100 years. I'm not going to go into the first and third quantiles right now. We'll talk about those next week. Um, this at the end here says NAs. And I want to show you, we're going to look in this data set and see if we can find an NA here for you to take a look at. Here we go. And you'll notice that if you look at this, we're just looking at what's in here. You can't, by the way, change anything in here. But you'll see this NA is grayed out, whereas everything else is dark. And this means that we're missing. We don't have the information about this person's age. So we're probably missing, we know when they've been admitted, but we don't have their birth date. So of all the patients in the data set, we are missing information about 6 of them. That's not too bad considering we have information, if we look up here, on 161 patients. So we're only missing 6, which is not terrible. In real life, you almost never have all the information about every single observation, especially in survey research. People, don't answer questions, or we don't know information, and sometimes we just leave it out. So this is one way that you can summarize this data. We're missing a little bit of information here because it doesn't tell us about how variable the data are about some measure of central tendency. So summary is a decent first glance at a variable that's numeric, but we can do a little bit more. And to do that, I want you to install, I think we actually did this before. If you haven't done this already, I want you to install the psych package, but I believe we did this the first time. So we're going to scroll down, and we're going to use a new package for the first time. And it's the psych package. So in order for us to use functions that are in the psych package, we're going to click the little box next to it. So I am going to make a note here in our script. Whoops. For the next function, remember, it would be helpful if I spelled it right, to require the psych package. And there's a function in the psych package called describe. So I'm going to type describe, and I just want to show you this. As I'm typing this, again, it tells us what we can do with that. So the X next to it just means we're going to put a variable name in. So we're going to say age. Now there's a bunch of other things afterwards, those options after the comma, and those are just the defaults. And that goes a little bit outside the scope of this class. But when I run this row, I'm just going to hit run. This gives us a little bit more information. Actually, what I'm going to do to make this a little bit easier to read is I'm going to rerun it now that I am making things a little smaller here. So we'll give us ourselves a little more space over here. And now it's almost on one row. Okay, so this describes the variable age in much more detail. It doesn't tell us how many patients we have missing data for, but this N tells us the total number of patients that we have information on this variable. So we have information on 155, which is that 161 minus those 6 that we're missing. And we get the same information that we had above. So the mean age is 76.13, the median is 75.5, the minimum value is 64.6, the maximum is 100. But we get a little bit more information that I think is helpful for you. and that is this SD. This SD is called the standard deviation, and we explain it a lot more in the book, um, in making your case. But whenever you just use a measure of central tendency like mean or median, that in one or two, in one number tells you what's typical about this data set. So in other words, the typical age or the average age, we could say, for the patients in this data set is a little over 76 years. We want to know how dispersed the ages of these patients are around that measure of central tendency. So when you read research articles, and you've done this already, and you see a mean, you always see a standard deviation after that. And what this standard deviation of 7.13 years means is that on average, each patient varies from this mean of 76.13 by 7.13 years. So that's one thing. The median is also a typical value. You could use the median as a measure of central tendency instead of the mean. We do that frequently when there are a lot of outliers, and we'll talk about that next week when we look at box plots a little bit more. But what we typically report as variability in when we look at median is the range of values. So the range is this 35.54, and that is simply the difference between the minimum and maximum score. So if you take 100 and subtract 64.46, the answer is going to be 35.54. So my recommendation for you is when you report a median, also report the minimum and maximum scores. So you would say something, well, you'll write it up something like, I'm going to write it here, it doesn't make too much sense. The median age is 75.5, range something like 64.46 to 100 years. It's all units of years. You would write it like that. Or you would say the average age is 76.13 years and SD equals 7.13. And you, like I said, I'm sure you have seen that before. So that describe function is really helpful in telling us how many observations we actually have, the average, and measures of variability around that. The rest of this for now is sort of that's in this describe is outside the scope of this class, but you'll see the describe function becomes more useful later in the semester. And the last thing I want to show you as new today is just like when we were visualizing categorical variables in terms of a bar plot, we can visualize continuous variables or those that are made up of numbers in terms of histograms and box plots. So I'm going to show you a histogram today, and the function for that is super easy. It's just hist and age, and I'm going to show you how to annotate that a little bit in a moment to make it more readable the same way we made our bar plots more readable. And I'll run that for you. And here we have a histogram of age. And you'll notice here that it's there are labels automatically put onto it. It's a little bit easier to see. I just zoomed out so you could see this a little bit more. Now these are not bars like a bar plot is, in that we have patients of all different ages, and R creates what are called, instead of bars, these are called bins that are sort of optimized to display this data in a way that makes the most sense. If we had a bin for every year, we would have somewhere between 60, we'd have like 40 bins. What you see R has done here is create bins of 5-year increments. So we have patients in the ages of 60 to 65 in this bin, from 65 to 70 in this bin, and so on. So we have sort of, we get a sense looking at this that we have very, very few patients in the 60 to 65 range, but we have a whole bunch in this range here. We have most patients in the 65 to say 80-year range, and then we get smaller and smaller groups. And of course, at the very end, we have not very many people in at the 95 to 100 range. So this is how we visualize, and this is one way of visualizing variables that are made out of numbers. I want to just show you this. Notice that when we looked at the bar plots last week, these bars have spaces between them, and that shows us that these are discrete variables, that there's no continuity before them. People, at least in this data set, are either female or male, and there's no sort of in between. In histograms, the bins are touching each other because it denotes sort of the continuous nature of this data. And if, for instance, this bin was missing completely, it would tell us that there were no patients in this 65 to 70-year age group. So I'm going to just show you one more continuous variable, and then you will have a little bit of homework to do for this. So let's just pick something else. We had age, and I wanted to save the LOS variable for you for something else, for homework actually. So this TCAT sum, and this is described much more in the book, so I want you to read the description of this data set. Tells us about activities of daily living for patients. So I want you to, on page 41 is a summary of each of the variables, these CATS variables, 1 through 6, and then we have IAD variables, 1 through 7. So each of these CATS variables, 1 through 6, talks about an activity of daily living for each of these patients, and how independent they are in each of these activities. So CATS 1 talks about bathing, and higher scores indicate more independence. So if a patient was assessed on CATS 1, which is bathing, that means they can bathe themselves and they receive no assistance getting in or out of the tub. If they get a 2, that means they receive assistance in bathing only one part of their body. So that would be something like a patient that has a difficult time, say, reaching their feet because they would have to bend down. And then the least independent would be 1. They would get a score of 1, and that means they receive assistance in bathing more than one part of their body. CATS 2 talks about dressing, CATS 3 toileting, transferring, continence, and feeding. This TCAT sum is a summary of all, it's a scale based on those 6 measures of activities of daily living. So higher scores on this TCAT sum indicate more independence. So I just want to show you this, now that you know a little bit about that. But look on page 41, that gives you more information on that. So if we want to describe TCAT's sum, whoops, I spelled that wrong. It gave me an error. It says object not found. Now, if you get something that says object not found, it means that you either did not attach your data set or you spelled something wrong. Here I spelled something wrong. And when we go up, we have information on 160. Oops. Oh, I used describe. That was, don't know what I did there. Describe tcat sum. Ah, that's what it is. I didn't use the summary function, but that's okay because this is really better. Um, we'll put that in there just for consistency. Okay, so we have information on 160 of our 161 patients. The lowest value is 6, which means that the patient scored the lowest on all 6 of those um, activities of daily living because we just added them up. So we do have some patients that have the lowest level of functioning, and we also have patients that have the highest level of functioning because 6 times 3 is 18. So that would mean that they got a 3 on each of those. We can look at the mean score. That's 15.62. That's pretty high. That's more than 15 out of 18. And we do have some variation. By the way, if all of our patients got an 18, our standard deviation would be 0 because it would mean there was no variation among the patients from the mean. The median score, however, is very high. So when we look at our histogram, we're going to see a lot of scores skewed towards that high end because it means half of our values fell at 18. So we're going to see things skewed a little bit differently than we did last time. And the range again is 12, but again, don't just report the range as the difference between the minimum and maximum. Report it as the minimum and maximum scores. That makes the most difference, makes the most sense. Okay, so let's take a look at the histogram for that. And when we hit run, we can again see that this, most of the patients, even though we have some very old patients, most of them score somewhere in the 16 to 18 range. So that's pretty good. Now, when we looked at our last histogram, age kind of makes sense on the x-axis here. If you weren't familiar with what tcat sum is, this makes no sense and this makes no sense. So we can annotate this in the same way that we did the bar plot, but we will keep the Y label of frequency the same. Now this time we're going to change the X lab, and we're going to call this ADL, that's Activities of Daily Living score, and our main equals patient ADL scores. And you'll see that it will overwrite when we run this the default. So when we run this, looks much more reasonable. And if you look, I wanted you to see this. After the comma, just like in the bar plots, we can add labels. But in the bar plot, we wanted a Y label, so we called it Y lab equals. But here in the histogram, we wanted a label for our x-axis. So you can think about changing labels on any diagrams that you make. And again, you can export this the exact same way you did the bar plots. And I just wanted to show you one more bonus in case you're interested more in learning more about RStudio Cloud, because this is a very, very powerful tool, and I really only teach you the beginnings of it here. But there's a lot of resources for learning about R for free, and I wanted to just show you this here. I purposely didn't close this at the beginning of class today, and I wanted to show you what's in these primers. Now, this is all free learning, however you want to make use of it. This is just whatever you want to do. But this is really getting started in a really interesting way, and you can see that they are continuing to create more primers as you go. But for instance, if you just want to get some information about, basics of using RStudio, you can learn visualization basics. I'm showing you some of that to you here, but you could actually work through an entire course on doing that alone. They use a package in here called ggplot2, which is just a fantastic product. But I wanted to just show you that in case this is something that you're interested in doing on your own and learning more about. Because I'm hoping that once you leave Montclair State, you can take this into your own agencies and do a little bit of evaluation work that can help what you do. So, our script here is saved, and I hope you found this useful.